Now, before we dive in, let me set the scene. It's July 1st, 2025, and astronomers at the Atlas Survey Station in Chile are doing their usual routine, scanning the skies for anything interesting. Suddenly, they spot something that makes them do a double take. There's this object moving through space, and when they calculate its trajectory, they realize something incredible. This thing isn't from around here. I'm not talking about coming from the outer solar system. I'm talking about coming from another star system entirely. This is 3I/Atlas, and it's only the third confirmed interstellar object we've ever detected passing through our solar system. Let's put this in perspective for a second. The first interstellar visitor we ever spotted was Oumuamua back in 2017, which caused a massive stir because of its weird cigar shape and strange acceleration. Then came 2I/Borisov in 2019, which was more well behaved and clearly looked like a comet. Now we have 3I/Atlas, and folks, this one is turning out to be the weirdest of the bunch. And the best part? It's happening right now. We're not talking about something that happened years ago. This comet is zooming through our solar system as we speak, and it's going to reach its closest point to the sun on October 29th, just 2 weeks from today. So, what makes 3I/Atlas so special? Well, buckle up because this gets wild. First off, this thing is fast. When I say fast, I don't mean your average comet fast. I mean interstellar highway speeds. It's traveling at a hyperbolic velocity of 58 kilometers per second relative to the sun. That's about 130,000 miles per hour. To put that in perspective, if you could drive your car at that speed, you could go from New York to Los Angeles in about 90 seconds. When it was first discovered, scientists clocked it moving at 221,000 kilometers per hour. This comet is in a serious hurry, and it's not slowing down for anyone. Now here's where it gets really interesting. You know how when you throw a ball, it follows a nice curved path and eventually comes back down? That's called an elliptical trajectory. Well, 3I/Atlas isn't following an elliptical path. It's following what's called a hyperbolic trajectory, which basically means it's going so fast that the sun's gravity can't capture it. It's going to swing by, say hello, and then zip right back out into interstellar space, never to return. The orbital eccentricity of this thing is 6.137, which is astronomer speak for ridiculously hyperbolic. In fact, it's the highest eccentricity ever recorded among the three known interstellar objects. This comet is basically doing a cosmic drive-by. But wait, it gets better. Scientists have been studying 3I/Atlas with some of the most powerful telescopes we have, including the James Webb Space Telescope, and they've discovered something absolutely fascinating about its composition. This comet is absolutely loaded with carbon dioxide, way more than any comet we've seen before. When the Webb telescope analyzed it back in August, they found that the ratio of carbon dioxide to water in this comet is about 8 to 1. Let me repeat that, 8 parts carbon dioxide to 1 part water. That's bonkers. Most comets in our solar system have way more water than CO2. This is like ordering a soda and getting 80% carbonation and only 20% actual liquid. It completely breaks the patterns we see in solar system comets. And here's where my favorite part comes in. Remember how I mentioned this thing is spraying water? Well, NASA's Swift Observatory has been watching 3I/Atlas, and they detected something called hydroxyl emissions, which is basically the fingerprint of water molecules being broken apart by sunlight. When they calculated how much water this comet is losing, they found it's producing about 88 pounds of water per second. That's like a fire hose running at full blast, except instead of your garden, it's spraying water into the vacuum of space. One scientist literally described it as spewing water like a cosmic fire hydrant, which is probably the best description I've heard all year. Now here's what makes this water production so weird. Normally, comets start releasing water when they get close enough to the sun that the ice on their surface starts to sublimate, turning directly from ice into gas. It's like when dry ice creates that spooky fog effect. But here's the thing, 3I/Atlas is producing water at a distance where it should be way too cold for normal sublimation. It's releasing water much farther from the sun than we'd expect. Scientists think this might have something to do with that crazy carbon dioxide content. The CO2 might be sublimating first and literally ripping water molecules along for the ride. It's like when you open a shaken soda bottle and everything comes spraying out. The CO2 is the fizz, and the water is just along for the explosive party. Let's talk about age for a second, because this is where things get mind blowing. Based on its composition and trajectory, scientists have estimated that 3I/Atlas is somewhere between 7.6 and 14 billion years old. Let that sink in. Our entire solar system is only 4.6 billion years old. This comet might have been wandering through the galaxy for billions of years before Earth even existed. It could have witnessed the formation of entire generations of stars. It might have passed by alien worlds we can only dream about. This thing is literally older than our cosmic neighborhood, just casually cruising through like it owns the place. Scientists think 3I/Atlas probably comes from what's called the thick disk population of the Milky Way, which is a group of older stars and objects that formed early in our galaxy's history. If that's true, this comet has been on an epic journey through space for at least 7 billion years. In the last 10 million years alone, it's passed within about 3 light years of 25 different known stars. Just imagine the things this comet has seen. It's the ultimate cosmic tourist, and now it's visiting our solar system. Oh, and speaking of visits, here's something really cool. On October 3rd, just a couple weeks ago, 3I/Atlas made a close approach to Mars, passing within just 28 million kilometers of the red planet. Now, that might sound far, but in space terms, that's basically a cosmic near miss. The really exciting part is that during its closest approach to the Sun on October 29th, the comet is going to pass almost directly behind the Sun from Earth's perspective, which means we won't be able to see it very well from here. But you know who'll have a front row seat? The orbiters circling Mars. The Mars Reconnaissance Orbiter and other spacecraft at the Red Planet are going to get an incredible view of this interstellar visitor at its most active moment. How awesome is that? We're literally using robots on another planet to watch a visitor from another star system. Now, I need to address the elephant in the room, or should I say, the alien spaceship in the solar system. Shortly after 3I/Atlas was discovered, a certain astrophysicist named Avi Loeb, who you might remember from the whole Oumuamua controversy, suggested that 3I/Atlas might be an alien spacecraft because of some anomalous characteristics. This happened on July 16th, and let me tell you, the scientific community was not having it. Within days, multiple teams using 4 different powerful telescopes, including the James Webb Space Telescope, all confirmed the same thing. This is definitely a comet. It has all the classic signatures of cometary activity, including that massive water and CO2 production we talked about. It's got a coma, it's got outgassing, it's behaving exactly like a comet should behave, just with a weird composition because it formed in a different star system. Look, I get it. The idea of alien visitors is exciting, and who knows, maybe someday we'll actually detect one. But 3I/Atlas isn't it. What it is, though, is arguably even more fascinating. This is a natural object that formed around another star, possibly billions of years ago, that has traveled across unimaginable distances to pass through our solar system. It's carrying information about the conditions in a completely different planetary system, maybe one that doesn't even exist anymore. It's like receiving a message in a bottle from across the galaxy, except the bottle is made of ice and rock, and it's traveling at 130,000 miles per hour. The composition of 3I/Atlas is teaching us something really important. Planetary systems around other stars can be fundamentally different from ours. That 8-to-1 ratio of carbon dioxide to water suggests this comet formed in an environment very different from the one that created our solar system's comets. Maybe the star it formed around was a different type than our Sun. Maybe the protoplanetary disk it came from had a different chemical makeup. Whatever the reason, 3I/Atlas is proof that there's incredible diversity out there in the universe. Every star system might have its own unique fingerprint, its own special mixture of elements and compounds. And here's something that really gets me excited. The water that 3I/Atlas is spraying into space isn't just water. It's water from another star system. Scientists have also detected carbon monoxide, cyanide gas, and even atomic nickel vapor coming from this comet. These are the ingredients that could have seeded life in whatever planetary system this comet originally came from. When comets like this slam into planets, they deliver water and organic compounds. Our own Earth might have gotten a lot of its water from comet impacts billions of years ago. So when we look at 3I/Atlas, we're not just looking at a space rock. We're looking at a potential seed carrier for life, a delivery system for the building blocks of biology from a completely alien solar system. The fact that we can even study this object is pretty remarkable when you think about it. 3I/Atlas is incredibly faint. Its apparent magnitude is somewhere around 12 to 14, which means you absolutely cannot see it with the naked eye. You'd need a decent telescope just to spot it as a tiny fuzzy dot. But with professional observatories and space telescopes, we can analyze its spectrum, measure its composition, track its trajectory, and learn its secrets. We're living in an era where we can do detailed chemistry on objects from other star systems. How cool is that? Now let's talk about where this thing came from and where it's going. Based on its trajectory, astronomers have traced its path backward through the galaxy. It came from the general direction of Sagittarius, near the galactic center, though of course it's been traveling for so long that pinpointing exactly which star system it originated from is basically impossible. It might have been kicked out of its home system by gravitational interactions with giant planets, or maybe its star died and it became a wandering orphan. We'll probably never know for sure.
What we do know is where it is headed after it leaves US after swinging around the sun October 29 th. 3 Atlas will continue on its hyperbolic trajectory out of the solar system, heading back into the vast intimes of interstellar space. It will just keep going, possibly for another billion years or more, until maybe, just maybe, it encounters another star system and gives some future alien astronomers the same thrill we are experiencing right now. It is the ultimate cosmic nomad, and we just happened to catch it during a brief stopover. There's something poetic about these interstellar visitors. They remind us that space is just empty nothingness between stars. It is full of wandering objects, unseen remnants of planetary formation, orphaned comets and asteroids drifting through the galaxy. And occasionally, very occasionally, one of them passes through our little corner of space and we get this incredible opportunity to study it with an all century of these visitors in just 8 years. Oumuamua em 2017, Borisov em 2019, and now Atlas em 2025. That might sound rare, but astronomers think there could be thousands of these interstellar objects passing through the solar system at any given time. We are just getting better at spotting them.
In fact, the Atlas survey system that discovered 3I/Atlas was specifically designed to find these kinds of objects. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, and it's a network of telescopes that scan the entire sky every night looking for anything that moves. It was originally built to spot asteroids that might be on a collision course with Earth, but it's turned out to be fantastic at finding interesting visitors like 3I/Atlas. As our detection systems get better and we build more powerful telescopes, we're going to find more and more of these interstellar travelers, and each one is going to teach us something new about the galaxy we live in. So what's next for 3I/Atlas? Well, astronomers around the world are going to keep watching it intensely for the next few weeks, especially as it approaches perihelion on October 29th. That's when it'll be closest to the sun and most active. The heat from the sun will cause even more outgassing, and we might learn even more about its composition and structure. The Mars orbiters will be watching too, giving us unprecedented views from a different vantage point. And then, after its close encounter with the sun, 3I/Atlas will begin its long journey back out of the solar system, gradually fading from view as it gets farther and farther away. By the end of November, it'll probably be too faint for most telescopes to track. And then it'll be gone, another chapter closed in the story of interstellar visitors. But the data we collect during these precious few months will keep scientists busy for years. They'll analyze the composition, study the outgassing patterns, compare it to other comets, both local and interstellar, and piece together a better understanding of how planetary systems form and evolve around other stars. This is why I love astronomy. Right now, today, there's a 14 billion year old comet from another star system racing through our solar system at ridiculous speeds, spraying water and carbon dioxide into space, giving us a glimpse into the diversity of the cosmos. And we get to watch it happen. We get to be the generation that witnesses these incredible interstellar visitors and learns their secrets. How lucky are we? So keep your eyes on the news over the next couple of weeks, especially around October 29th. Scientists will be releasing new data and observations about 3I/Atlas as it reaches its closest point to the Sun. Who knows what else we might discover? Maybe there are more surprises waiting. Maybe we'll find even more unusual compounds in its composition. Maybe we'll learn something that changes our understanding of how comets form in other star systems. Whatever happens, it's going to be exciting. And remember, this is just the third interstellar object we've confirmed. There will be more. As our technology improves, we're going to spot more of these cosmic travelers passing through our neighborhood. Each one will be unique. Each one will have its own story to tell. Each one will carry information from distant and alien worlds. We're living in the golden age of interstellar object discovery, and it's only going to get better from here. The spectroscopic analysis alone is fascinating. When light from the sun hits the comet and reflects back to us, or when the comet's materials sublimate and glow, that light carries a signature, like a barcode that tells us exactly what chemicals are present. Scientists can look at specific wavelengths of light and say, that's carbon dioxide, or that's hydroxyl from water. It's like being able to taste a dish and identify every single ingredient, except we're doing it with light from an object millions of miles away that formed around a completely different star. The level of precision we have nowadays is absolutely incredible. Now let's talk about where this thing came from and where it's going. Based on its trajectory, astronomers have traced its path backward through the galaxy. It came from the general direction of Sagittarius, near the galactic center, though of course it's been traveling for so long that pinpointing exactly which star system it originated from is basically impossible. It might have been kicked out of its home system by gravitational interactions with giant planets, or maybe its star died and it became a wandering orphan. We'll probably never know for sure. What we do know is where it's headed after it leaves us. After swinging around the sun on October 29th, 3I/Atlas will continue on its hyperbolic trajectory out of the solar system, heading back into the vast emptiness of interstellar space. It'll just keep going, possibly for another billion years or more, until maybe, just maybe, it encounters another star system and gives some future alien astronomers the same thrill we're experiencing right now. It's the ultimate cosmic nomad, and we just happened to catch it during a brief stopover. There's something poetic about these interstellar visitors. They remind us that space isn't just empty nothingness between stars. It's full of wandering objects, ancient remnants of planetary formation, orphaned comets, and asteroids drifting through the galaxy. And occasionally, very occasionally, one of them passes through our little corner of space, and we get this incredible opportunity to study it. We've now seen 3 of these visitors in just 8 years. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. That might sound rare, but astronomers think there could be thousands of these interstellar objects passing through the solar system at any given time. We're just getting better at spotting them.
In fact, the Atlas survey system that discovered 3 Atlas was specifically designed to find these kinds of objects. Atlas stands for Asteroid Terrestrial Impact Last Alert System, and it is a network of telescopes that scan the entire sky every night looking for anything that moves. It was originally built to spot asteroids that might be on a collision course with Earth, but it's turned out to be fantastic at finding interesting visitors like 3 Atlas. As our detection systems get better and we build more powerful telescopes, we are going to find more and more of these interstellar travelers, and each one is going to teach us something new about the galaxy we live in.
The technology behind these discoveries is worth appreciating for a moment. The Atlas system uses relatively small telescopes, but what makes it powerful is that it surveys huge swaths of sky repeatedly. It's like having a security camera that watches the entire neighborhood instead of just your front door. When an object moves between observations, the computer systems automatically flag it for further study. This is how we catch these fast-moving interstellar objects before they slip away. Without automated survey systems like Atlas, we'd miss most of these visitors entirely. So, what's next for 3i/Atlas? Well, astronomers around the world are going to keep watching it intensely for the next few weeks, especially as it approaches perihelion on October 29th. That's when it'll be closest to the sun and most active. The heat from the sun will cause even more outgassing, and we might learn even more about its composition and structure. The Mars orbiters will be watching too, giving us unprecedented views from a different vantage point. And then, after its close encounter with the sun, 3i/Atlas will begin its long journey back out of the solar system, gradually fading from view as it gets farther and farther away. By the end of November, it'll probably be too faint for most telescopes to track. And then it'll be gone, another chapter closed in the story of interstellar visitors. But the data we collect during these precious few months will keep scientists busy for years. They'll analyze the composition, study the outgassing patterns, compare it to other comets, both local and interstellar, and piece together a better understanding of how planetary systems form and evolve around other stars.
One of the most exciting aspects of studying 3D Atlas is what it tells us about the diversity of planetary systems. Before we started finding interstellar objects, we could only study comets from our own solar system. Sure, we could find exoplanets around other stars, but those are massive objects that we detect indirectly. Comets are much smaller, and until recently, we had no way to study them from other star systems. Now, with objects like 3D Atlas passing through, we are getting direct samples of material from alien solar systems delivered right to our doorstep. It is like the universe is giving us free samples, and each one tells us something new about how diverse planetary formation can be.
The high carbon dioxide content in 3i/Atlas, for example, might tell us about the temperature and chemical conditions in the protoplanetary disk where it formed. Maybe that star system had more carbon-rich material. Maybe it formed farther from its star where CO2 could condense more easily than water. Or maybe the dynamics of that system's formation were just fundamentally different from ours. Each possibility opens up new questions about how planetary systems form and what factors determine their final composition. This is why I love astronomy. Right now, today, there's a 14-billion-year-old comet from another star system racing through our solar system at ridiculous speeds, spraying water and carbon dioxide into space, giving us a glimpse into the diversity of the cosmos. And we get to watch it happen. We get to be the generation that witnesses these incredible interstellar visitors and learns their secrets. How lucky are we? Think about it this way. 100 years ago, we didn't even know other galaxies existed. 50 years ago, we had no confirmed planets around other stars. 20 years ago, we hadn't spotted a single interstellar object passing through our solar system. And now, not only have we seen 3 of them, but we're analyzing their chemical composition with space telescopes and tracking their trajectories with networks of automated observatories. The pace of discovery in astronomy is absolutely breathtaking, and it's accelerating. So keep your eyes on the news over the next couple of weeks, especially around October 29th. Scientists will be releasing new data and observations about 3i/Atlas as it reaches its closest point to the sun. Who knows what else we might discover? Maybe there are more surprises waiting. Maybe we'll find even more unusual compounds in its composition. Maybe we'll learn something that changes our understanding of how comets form in other star systems. Whatever happens, it's going to be exciting. And remember, this is just the 3rd interstellar object we've confirmed. There will be more. As our technology improves, we're going to spot more of these cosmic travelers passing through our neighborhood. Each one will be unique. Each one will have its own story to tell. Each one will carry information from distant and alien worlds. We're living in the golden age of interstellar object discovery, and it's only going to get better from here. The future of this field is incredibly bright. NASA and other space agencies are planning new survey missions that will be even better at spotting these interstellar visitors. There's talk of missions that could actually chase down an interstellar object and study it up close, maybe even return samples to Earth. Can you imagine holding a piece of rock that formed in another star system? That's not science fiction anymore. That's a realistic goal for the next few decades. Thanks for watching, and if you enjoyed learning about this ancient cosmic visitor, make sure to hit that like button and subscribe for more space content. Drop a comment below and let me know what you think about 3I/Atlas. Are you as excited as I am about these interstellar visitors? What do you think we'll discover next? I'll see you in the next video, and until then, keep looking up at the stars. You never know what might be passing through.